Welcome to Defen number episode 41 and 42-ish. Because we were just discussing if we want to make it 42 already, because we've been trying to get the answers for life, universe, and everything with Mr. Timothy Baldridge.
Hello.
So, welcome to the episode.
Thank you. I don't know that I'll be able to provide any answers to life, universe, or anything, but it's great to be here.
We're looking for anything. Come on.
Yes, something. So, before we start, we just want to, we wanted to say thank you to the people who are supporting us, especially on Patreon. Ray, do you have a couple of members that you want to say thank you to?
Yeah, I mean, actually, it's quite phenomenal, actually. We've got like over 20 members now. And so it's pretty amazing, the response from the community to this request. And, people are being very generous. So, yeah, I want to thank some of the longer sponsors. And what we'll do is we'll try and make a few name calls for every episode, because we can't go through every one of them now, But yeah, I want to make a call out to the guys that have been doing it for the longest. And that's Claudio. You know who you are.
Yes.
And to Sebastian and to Arturas, to Norman and to Ruben. These guys have supported us for the longest time, and their generosity is amazing. So yeah, thank you very much.
Yeah, thanks a lot. So
we'll definitely call out a few more people on the next episodes. But this is great. It helps us to cover the costs, and maybe we'll have a look at some. We've already sent Wouter to a conference in Berlin, and now he's a closure programmer. So the love is being spread, which is good.
So we are paying people to get into closure.
Someone's got this now. Someone's got to do this. Yes. Anyway, yeah, no, it's really great. Thanks everyone. Really good stuff.
Thank you. Thanks a lot. Yes.
Thanks to everyone else who's doing it as well, and we definitely will get to everyone on the list.
Exactly. So let's get on into the episode now. So Tim, first, can you give us some idea about what you're working on? Of course, there are lots of closure libraries that you built over the period, and you are a full-time closure programmer as well.
Yes.
Working on closure.
Yeah. So I currently work for Cisco here in the US, and I work on their threat grid team, which is we kind of do analysis of malware and in some fairly innovative ways. And I work on a team that indexes the data that we extract out of viruses and the like, and index it and present it in a way that can be easily searched and that sort of thing. So that's my day job. I tend to do a fair amount of database programming, logic, database, that sort of stuff there as well, query engines and that sort of thing. And that's for about half a year now. That's been about what I've spent a lot of my time on. I moved on from Cognitect, I guess it'd be about 10 months ago, and kind of just took a break from open source at that point. It's like, I've been doing open source on the side for a while, and it's once in a while, it's just nice to sit down and just do work and keep it at work, But I always have hobby projects and stuff kicking around that, stuff, programming languages and the like, I like to hack on.
But what was your programming journey to get to this point? With the languages?
Yeah. Hold on.
You must have started off with some crap, so let's get the
get that out of
exactly.
Let's get out of the way,
Yeah. So I started programming back when I was 10 and a half, and I found a book in the library on how to program BASIC, and this was BASIC with the line numbers, right? And the funny thing is at that time, which would have been early 90s, I guess, like those versions of BASIC didn't exist anymore. Like it was like Z80 BASIC, and I forget Acorn and some of this other stuff, and here I am in DOS with GW BASIC, right? So I was like hand translating out of these books, and that thing doesn't exist in this version of BASIC. But not too long after that, and what's actually cool is my dad encouraged me a lot in that sort of thing too. So growing up, my dad worked at a at a university where computers were kind of like scientific equipment and stuff. So, you know,
Yeah.
we were one of those families that always had a computer in the home, but not because, you know, I was a millennial. It was just because like, you know, my dad built a Z80 from scratch. And so let's, you know, we now have that in the house. From there moved on to QBasic and learned, you know, functions. What are those? Why do I need functions when I have Go2? From there, you know, C, Python, a little bit of C++ in there. And then really though, I think, so that was all the way up through high school, and I started doing IT work and kind of got to a point where it was like, do I want to do IT support or programming? And I found myself enjoying programming more and more and just kind of focusing on that. So I think most of my work at that time was in Python, just small scripts and stuff, Visual Basic. And from there, I worked with Microsoft for a while, and that was where I learned C#, which is kind of, you know, hey, you got to learn C# or Java at some point. And so that kind of got me into the mainstream programming. But around that time is when I discovered Erlang. So Erlang was my first functional programming language. And, you know, what I found fascinating about that is, and I encourage people to do this with any language like Clojure or whatever, is like, I remember reading about Erlang. Hey, this is a language where you don't share memory. There's no such thing as an if statement, and we don't have loops. And you're like, well, how do you do anything then? You know? And so you can do two things, right? One is you can say, wow, this language must be crap. Or you could say, well, hey, obviously a lot of people use this. What are they doing, you know, differently? And so you learn about pattern matching and recursion and, you know, tail calls and that sort of thing, and realize, hey, it works. But after a while, I just kind of got working in Erlang. I got to the point where the actor model was cool, but I found myself fighting it more than anything else. That I wanted to treat all my memory in a shared way, immutable still, but in a shared way. And so I, you know, got asking what languages are there out there that have cool concurrency models, and Erlang was one. And then people started mentioning, hey, there's this new language called Clojure. You know, this is 2009 or so. And so I got into that. And then, of course, you know, I articles I read around the time were like, you know, everyone should learn a Lisp because it'll alter your brain, you know? so that's my journey all the way from
did it
from basic on. Yeah. So you're going to say?
Did it alter your brain?
Yeah, it broke it, I think. But
that is one type of alteration.
Yes, right. No, I think it does. I think functional programming in general does that. And then Lisps with just the simplicity of Lisps, of being able to see you know, how eval and apply work to build this interpreter. I mean, I think that's something that is kind of a point of enlightenment, is if you can sit down and just kind of write a Lisp in Clojure sometime. It's 100 lines of code. And you kind of realize, wow, all this stuff is so simple, you know, and yet powerful. Of course, the devil's in the details there, because it's also slow. So to make it faster, you have to add performance improvements, which add more code and make it more complex. But it's cool to see.
What about the sort of homoiconicity? You know, we're allowed to use big words here, so you know, fuck it. So that's the thing that really always strikes me, is like the REPL and the homo. And okay, we haven't got so much reader macros, but we've still got macros in Clojure.
Yeah.
You know, and those things are quite different. I mean, you know, I was more of a sort of C Java programmer, so I of course had heard of macros, but nothing like this, you know.
Yeah, absolutely.
So I was wondering how those affected you, or those made you think.
Yeah, I think that's something that you know, it's fascinating, because I had done a little bit of C++ before that, and there's like a lot of template meta programming in that. And I even in high school. So somehow in high school, I convinced. I was homeschooled, and
Right.
I somehow convinced my parents in high school to let me write a programming language as a school project. And so I've always kind of dabbled in compilers and stuff, and it's a horrible piece of code. It's I think I don't even think I have it anymore. But even back then, I was kind of thinking about, hey, I hate writing this code over and over again. What if I could have a way to tell the compiler to duplicate this, or do this but add 1 to this number every time, and so once if you write, like you said, in Java or these other languages, you end up writing the same code over and over, and you start thinking, hey, there's got to be a way I can generate this, and so in Java you do it by generating a source file. You can always write text out and then load that back up to the compiler, and that's crazy. But
So so with Clojure, when you started with Clojure, what kind of applications were you building? Is it consulting for different types of projects?
No, actually, so
anything?
back in that time, I was working on a C# app for a architectural firm in Wisconsin, and so it was we were kind of like in the HR department, and we were writing project management software, and it was very much a thing. I listened to Rich Hickey's talk on, Are We There Yet? And I remember listening to this at my desk while programming and just going down the list of everything he says like is wrong with software. And I'm actually typing it at that moment. It's like we had all sorts of problems with, mutability and all this sort of stuff. And I just slowly got more and more dissatisfied with that and decided to learn Clojure. And so I back in that time, I started the Clojure in Python project. And sometime we can talk about how hard that is to actually be a thing that would work. But that kind of got me learning Clojure. It's like, it forces you to read all of the source code if you're going to re-implement a language on a new platform. And so I did a lot of reading of Clojure and just kind of used that on the side to build up my Clojure skills. And I went right from that company to Cognitect. So Cognitect was really the first job I had in Clojure itself.
Okay. So the Python that you're talking about is Pixie.
No. So before Pixie, back then, I started a project called ClojurePy, and I don't even know that it's still out there. But the idea was basically compile Clojure to Python bytecode, and it's a little weird because there's a lot of semantics between Clojure and Python that don't quite match up. Things that are close but not quite there, and really Clojure really wants a nice JIT. PyPy exists for Python, but you have this weird world in Python where you either see Python or PyPy.
Or PyPy,
and it's like, so you're going to write half of ClojurePy in C, or are you going to write it in Python and then it only runs fast on PyPy, and I made a ton of mistakes back then too on that. But
did you check what was the language? It was Hi, HY?
Yeah, Hi is a new language. Yeah, that actually it still exists, and they do that. Now what they did was they basically wrote Lisp flavored Python. So all the Lisps are mutable. Python has this horrific view of closures where you can modify, like if you close over a variable, you can modify it in a closure, and it modifies it in wherever the environment was you took it from, which is like that's terrible. So there's some things like that Hi inherits, and then if I were ever to go back and do ClojurePy, it's like that's this type of thing that you would want to somehow paper over, and like ClojureScript does. So there's a lot of those sort of weird semantics in JavaScript, and they're kind of papered over in ClojureScript.
Okay. So I think first we need to talk about the biggest issue that we have. So Emacs or some other shit?
So I realized when I was coming to this podcast
that there was a pause.
I used to program in Emacs, and I now use cursive, and I was also raised vegetarian, and I'm not anymore, or vegan technically. So it's been great, guys. I guess we'll just end the podcast here, right?
No, I mean with Emacs, I think we have like I'm a vocal majority, and and Ray is just I mean he just needs to see the lights at some point.
Yeah, well, we're getting your nemesis on this program soon, so
It's like it's like 42 episodes, and I'm still trying to brainwash him. At some point, he's a bit slow, but he'll catch up to Emacs eventually.
Yeah, I used to use Emacs, and I started sitting down the other day, and it's like I have coworkers that just sit. I mean, like they have Emacs just perfect. Everything's configured, and I am that way about certain types of certain things in my life. Behind me is a painting from Skyrim. And I will sit down and I will mod Skyrim. It's some guy fighting a dragon. I will mod Skyrim for tens of hours and, install hundreds of mods and get it just the way I want. And I just don't care about Emacs like that. So
that makes sense. I mean, you need to have at least.
I remember, you have got dark mode in cursive, so.
Yeah, right.
I mean, these days, I think I'm even more extreme these days because I'm using, I stopped using like iTerm or something with the tabs and all that shit. So I switched to Alacrity or something. That's like a GPU accelerated Rust. It was written in Rust.
Nice.
It's a terminal emulator. So I have tmux and then Emacs terminal within the tmux, and then that's it. Only one huge thing with it's super fast and it's really nice. Anyway, I think I'm going back to the 70s, how people used to program in the 70s, and then using the GPU.
Yeah. You always wear flares when you're doing that, VJ.
Yeah, pretty much. Anyway. Staying alive. Yes, exactly.
That's right.
Okay.
Anyway.
On that note.
Yes. Let's talk about Clojure.
Yeah.
So I think maybe a couple of still positive things before we get on to the
wow.
Go. Let's keep it positive all the time. Come on.
Yes, of course. Before we get on to the serious stuff or friction that is in the community. So tell us a bit more about CoreAsync. Like what was your contribution and how did you start with this thing?
Yeah. So CoreAsync, I'm trying to remember what the initial kickoff thing for that was, but early 2013. So this is a few months after I started with Cognitect, I believe, come to think of it. Basically most languages at that point had a form of async await, or were getting a form of async await. Python, C#, JavaScript has it now. They didn't at the time. Yeah. And this sort of stuff was starting to exist in Java as well. I don't know what the story is there yet. I don't know if they have those keywords. At any rate, a lot of languages were getting this. And so,
and soon Python as well.
Yeah. And so Rich said, hey, let's figure out how we want to do this in Clojure. And so at the time it was going to be all promise based. It was we needed some sort of transformation macro like Go. And so Rich said, hey, you enjoy compiler stuff. Would you like to write this? And so I got working on that. And then Rich went to a conference, and I forget what the conference was. And he came, and there was a talk there by the people at Go, and they talked about Go channels and all this. And he came back and he's like, well, I hope this isn't going to, cause you to rewrite a ton of code, but we're going to use channels because this is way better. And it is,
Yeah.
And so, there was a period of time where the Go macro worked basically off promises, and that sort of thing. It wasn't easy, and there's really no change to the macro based on that. But so primarily that library was a collaboration between a bunch of people at Cognitect. So I myself and Gotti, you know what? I don't say his last name often enough to not butcher it. Shaban? Is that how you say it?
Shabayan.
Yeah.
Or something
Sorry,
like
Gotti.
Yeah.
But he and I
just God for
collaborated.
short.
Right. He and I collaborated a lot on the Go macro. Rich wrote all the most of the channel stuff. Alex Miller did a lot of the supporting code in there too, and then other people at Cognitect pitched in for the different parts of CoreAsync. There's a weird like reordering queue, time-based queue thing in there that somebody wrote. I forget who it was now, but and then it was kind of a collaborative piece of work.
But how do you contrast this with, because you had experience with other concurrency models
Mhm.
like actors, for example, in Erlang. So how do you explain, like, I don't know, like I'm five. Well, I'm five in this
Yeah, yeah.
domain anyway. So
Yeah, so
if I can get it, then that's easy.
yeah, so there's the concept involved with core async is called CSP,
Yeah.
communicating sequential processes. And I've been doing a lot of work with continuation passing style, which is CPS, and so I had to think
Hmm.
about the acronym. It's a completely different thing. Yeah, so CSP really talks about the idea that you have processes. You can think of them as a process in an operating system, and then you have channels in which they talk to each other. And there's even a form of calculus involved in that,
Hmm.
and it's
Yeah,
pi
it's
calculus. Yeah, pi
pi
calculus. Yeah,
calculus. Yeah.
because as it turns out, the most basic form of a channel is a handoff. If someone is trying to put onto the channel, the put does not succeed until someone takes the value. And so there's a
Mm.
certain amount of reasoning that can be done there about the correctness of programs and some other things like that.
Hmm.
Because you have that very, it's not as asynchronous. There's no buffers involved, and so it's a lot easier to reason about.
Hmm.
But that contrasts with the actor model in some interesting ways. So in the actor model, you have the first class thing in an actor model really is the actor itself. So actor
Mm.
models, you can do kind of three things. You can start an actor can send a message to another actor, and an actor can say how the next message it receives should be handled. And that's like the core of what the real actor systems are. Erlang adds other things onto that and whatever. But
Yeah.
and then CSP says something different, and that is you have processes and you have channels. And so all you do is put something on a channel and hope somebody on the other end takes it. So the first class thing in that sense is the channel, which works fairly well in the way we build a lot of our systems today. I've built systems where you scale that up, where your processes are a machine, and then you have a
Hmm.
distributed queue, Kafka,
Yeah.
RabbitMQ, whatever,
Mm.
and you just put something on the queue and you don't care what happens to it. Somebody will pick it up and do something. But there are some differences there, and I think that's something that we haven't seen explored in the closure space, and that is there's been attempts to do Erlang's OTP. So Erlang has this idea of
Yeah.
OTP, which is like this whole framework of how to restart processes, how to do these sort of things. That's harder in CSP, and it's outright impossible in Clojure's core async because you can't even talk about processes in
Mm.
core async. Processes are not a first class thing. They're not reified. You can't say, is this thing running, because you have no way of saying thing,
Yeah. Yeah.
And so I think there's work to be done in that area. And I'm not sure what that looks
Yeah.
like.
But what was the reasoning behind picking CSP based concurrency versus, I don't know, bringing actors into Clojure? Is it because some other libraries are there already, like Akka?
Yeah, so
Or
there's a couple things there. One of them is actors in and of themselves. So what I said earlier is interesting. Those three primitives are all that's really required for an actor-based system, and then one of them is send a message to another mailbox. That is, or
Mhm.
to another actor. It's really a mailbox. Just you send
Yeah.
a message
Yeah.
to an address. Like sending a message in the mail, you don't know if it got there. There's no guarantees it
Mhm.
got there. It's asynchronous. You can just send a fire hose of mail to somebody, and who knows what's going to happen. And
Yeah.
so, I think it was Rich I heard that said this first. What is the first thing people do with actor systems as they build a queue? And it's kind of true. It's like, what is the first thing you want in an actor system? Well, you want acknowledgement. Like, I
Yeah.
sent the message and I wait for a reply. So what if I send it and they got it, but I never get the reply? So you
Mm.
have to keep resending the message until you get a reply from them saying, yeah, I got that. And they have to keep sending back to you until you get that. And so you end up building a certain amount of communication on top of that. And when you're all done, that's a channel in a way, right?
Yeah. Yeah. Yeah.
And so the actor model works great in distributed systems where, as it turns out, the network is unreliable. You send a packet to a
Mm.
machine, you don't know if it got there. If they acknowledge they send an ACK, you don't know when the ACK's going to get there.
Yeah. Yeah.
And but on a local box, it's interesting because you can build CSP on a machine itself because you have things like a lock, you have locks, you can kind of a transactional type system is possible to build on a machine. So in a lot of ways, Clojure has this philosophy of, let's not start with the worst case scenario, which is a distributed environment. We're gonna start with what we can do on the local box, immutable data, shared access, agents, atoms, those sort of things you can't build in a distributed system. But that doesn't limit us from using those in a single system.
Yeah. But in that case, isn't that the difficulty to scale it up to the distributed systems?
It is.
Then you need to bring in different kind of semantics into the system.
It is, yeah. And I think that's something where, Core Async does help you with the mindset of you're used to building software with queues, and then we're going to go and we're going to use a distributed queue, so you can kind of swap out that channel for a queue. But there are semantic differences, and there's like a lot of things in Clojure gives you a tool. Core Async gives you a toolbox, right? So I think it would be great if there was a more cohesive view of what it's like to build systems here with this sort of thing.
Yeah.
But on the other hand, the more you work towards that, the more you have, here's how you build a distributed system with Core Async. Then stuff outside of that box, once you give someone a hammer, they're going to look for nails, I guess is the way of saying it, right?
But there was this effort to build distributed atom some time ago. So probably somebody from Cognitect. I'm not sure if you.
Yeah. So years ago there was a system
based on the using Zookeeper and MongoDB, and then trying to build something.
Yeah, and that I think one of the last issues was, if you go to what was the name of it now? Avowed?
Yeah, Avowed. Yeah, exactly.
Yeah, one of the last issues in the GitHub repo is, I want to say it was, I'm not going to name names because I forget who it is now, but basically someone said, hey, if you go look at the Zookeeper spec, this can never work. And basically that was the end. Yeah. Because as it turns out, there's problems. Like Clojure is very much based around this idea of things existing a certain way within a computer itself, that you can do things like validation. You can do things like atomic updates and that sort of thing.
Yeah.
And once you get in a distributed world, that's not the case. And I tell people that too. It's like, I have actually sat down and written like a channel, a Core Async channel that works across a network, except it doesn't. There's still those little tiny things where in these cases, it doesn't quite work. If you pull the network plug, it's going to have different semantics than it did if it's within the same box, And so the question there becomes, should we just use a different programming paradigm in those cases?
One of the things that, and again, I don't know, to me, it's something which I don't know why it can't be done, but Rich seems to be against it, is this concept of like knowing a bit more about what's going on in Core Async. So understanding how big the channel is, how big the buffer is, inspecting what's in flight. That seems to be missing, and that seems to be, to me, quite a if we could have that data, more tools could be built on top of it. But that seems to be kind of almost a deliberate design choice to say, okay, we're not going to give you that. And that to me, I would say the problems with Core Async are like that, like, lack of instrumentation or lack of ability to introspect or look into that thing. And then secondly, I think that gives problems when you're getting stack traces or you're diagnosing what's going on. Well, where did it go wrong? What happened? Where were these threads? That doesn't come across very well on a podcast, but crossing the streams in some way.
No, I think you're right in the sense that sort of thing is needed. Now, I will be quick to say I have never heard Rich say that as a, we don't want this.
All right, okay. Yeah.
In fact, I've heard kind of the opposite, that, it would be nice to have more monitoring and this sort of thing. But
Okay.
But it's one of those things where it takes a certain amount of design thought, right? And I've gone down that road too of saying, do I I want to devote a year of my life to figuring out how this should be done, and then of course there'll be people that disagree with me or whatever, right? Um, but there are some things there that in core async that make it hard to do that without changing the library itself. So if someone wants to take that on, I would say one of the first things you probably need to do is fork the library and add some more stuff to it, like the Go macro itself. And there's people that have done this. There was a talk at a Conj or Closure West a while back where someone did that, and they installed hooks into core async, redefed a whole bunch of vars, and so they could do some cool things too, like actually diagram how the channels talk to each other,
Right.
or serialize it, where you could step through a core async program by pausing the channels, and that's great. So the thing is there though is those hooks have to be there. And
Yeah.
so, I would say what would need to be done in core async would be to add those hooks in the main line, or someone needs to fork it, and add that stuff in. But
I guess the biggest question to me is like, it feels a bit like nothing's happened with it for a long time. It's like 0474 and that's it. I mean, is it still actually, are people still looking at this thing? Is it still like getting some love?
well, I think that's the age old question, right? For a lot of closure libraries, right? Is it perfect or is it dead?
Yeah. Well, no, it's not perfect.
and
that's an interesting dichotomy.
I would agree with that too.
Okay.
But there's So it's been a few months back, not a few months, a few years now. It's now core async is part of the mainline closure development process. So spec, tools dep, I think is part of that. Closure core, or the closure language itself, and core async are all kind of under the umbrella of using Jira and that system, and so it does run into one of those problems of, I think there's things there that need to be fixed, but they're design questions, and it's a little hard getting traction to improve things in closure, or libraries managed like closure, if they're design questions, because it just requires someone to sit down and think of all the scenarios, and then run it by the powers that be to make sure that it's acceptable, I guess, and that takes a lot of time.
But this is one of the interesting things in the closure community, right? The entire discussion around the development process and lacking some sort of a direction. Because recently I started reading something about, probably I think most of the people know already, like I see a lot of parallels between the way closure is developed and then SQLite library that one is developed, because they have this core group of developers and only they can change the thing.
Mm-hmm.
And SQLite is available as a public domain thing, so you can use it for whatever you like. We don't want to complain, but there is a group that is that knows the stuff. But then I think the analogy breaks down, because SQLite is just, okay, you get it and then you use it, and closure is much more like a language. So I don't know, what is your opinion about, I don't know, having this kind of development?
Yeah, it's an interesting problem. So, probably some people are aware I've been a little vocal about this on Twitter. But
yes.
I think one of the things that needs to be said is, by all means, I consider myself some weird mixture of conservative and libertarian. So it's like, I very much believe in personal responsibility, personal agency. You can do what you want with what you did. I have no right to tell you what to do. And that's great. It is one of those things where, if you want people to continue to use something, it has to be appealing to them somehow, I guess. So I mean, that's one of the things with core async, is the question is do people stop using it because it has sharp edges, and they don't necessarily want to continue to experience those. And I know that's been true in my own work, is I actually at my current job, I don't even know where we use core async. I don't encounter it much if we do. And that's mostly because of, like you said, the rough edges, the stack traces, and and then these are things you experience in all sorts of libraries, stack traces and the rough edges, but is it something we could improve? Sorry, what I was going to say was all languages that use async have by default
Yeah.
more complicated code, and it's just kind of the nature of the beast.
Yeah.
But would it be possible to improve that? Could we somehow install some sort of hooks in the Go macro to say, hey, if this thing dies, let me know, or register it in a global atom to say what are all the Go blocks currently running, and these are all things that have their trade-offs.
Sure.
That's kind of the problem here is that I'll give you one example. There's been a debate for some time if using so within a Go macro you're not supposed to use a blocking take or put, and you can't use the parking take and put inside of a normal thread because it's a macro thing and it'll actually throw an error. But the other way you can do it, but you're not supposed to. So if you do a blocking take or put within a Go macro, it just hogs the thread. And so someone came up with the idea, and this has been around for a while.
That's only on
hey,
Java, by the way. It doesn't work on JavaScript.
Right. Yeah, exactly. But it's a nice construct to have. And so the question is, can we do some sort of macro logic or magic with dynamic vars to throw an error? That if you when you start the Go block, you set a little flag and say, hey, we're now in a Go block. And if you try to run this function, we do a check to say, are we in a Go block, and throw an exception. That does have a small performance penalty. We're talking about a hash map lookup for every time you do a block or take. So the question there becomes, is it worth the performance impact for removing this rough edge? And we can have a debate over whether it's right or not. But at the end, it kind of, you're like you said, it needs someone to stand up and say, this is the goal, the vision for the library. And I think a good counterexample to this is reactive extensions, which Microsoft developed, and it's kind of sort of not really a competitor to core async. It's kind of like core async and transducers but what they have is every single primitive in there even has like a visual diagram. If you put this in, here's the output, and the whole spec is designed from top to bottom so that when you go and implement it in a new language, it's easy to say, hey, you ported this wrong or you did that thing wrong. And they thought about how errors are propagated and errors are actually mentioned. But that comes back to that closure. That comes back to that closure philosophy of closure is in general optimized for correct programs. And so the question becomes, what does that mean for your everyday development? If you write a program that has a bug, do you really just want to, it's this. So at one point, if you had a transducer in a core async channel and that transducer threw an exception, it would hard lock the channel. Like you could never put anything else into that core async channel. Nothing could be taken out. It was just dead. There was no way to touch it or do anything with it. And so, so eventually we got error handlers in channels. That was one of those things where it's like, but wait a minute, we're no longer optimized for correct programs. But in that case, an incorrect program was painful enough, I guess, that it was worth putting that check in and that small performance impact, saying, no, don't do that is a fine response to an error, except for when, the way you say that is by shooting someone in the foot, literally, at that point, there's got to be a better way.
Who cares that much about performance though? I'm gonna just say that out loud, because to me, the whole point about this, like swapping threads and all this kind of stuff, is that it's all predicated on the fact that the CPU has got tons of time. I mean, it literally has got tons of time, and you're not going to be CPU bound. You're mostly going to be IO bound. So putting a check in there, and you're running closure for fuck's sake, which inherently is not, is an interpreted language, and I know you can compile it and all this kind of shit, but I don't know. It just seems to me like to go so far to say, okay, everything must be perfect because we are only optimized for that. I've got to. For me, it sounds like an excuse. It doesn't sound like. It sounds like a weird way of thinking about things. because putting in some checks or some guards to protect programmers against foolishness, known foolishness, it seems trivial. It seems like what everyone would do. So I've heard that, that optimized business, but I don't get it. I don't know where this is coming from. Actually, I've never actually heard Rich say it out loud. So maybe he does believe that fully.
I don't think so either.
But,
no, yeah. It's an interesting question, and the two things come to mind with that. One is I had a coworker tell me once that the Clojure community really fetishizes performance, like to an unhealthy level, and it's kind of true. It's like if you show somebody that using vec versus into vector is 2% faster, they're like, well, I'm always going to use vec. But it also reminds me too.
Honestly, please. The most of the Clojure people are not that.
But it's true. I mean, like people start to think. They extrapolate that. One of my favorite examples there is multi-methods, right? I was working with multi-methods once, and I asked someone, is there a faster way to do this with multi-methods? And they're like, have you benchmarked it? Like, no, I haven't benchmarked it. And they're like, benchmark it, and then we'll talk about it when you can prove that multi-methods are slow. And I never went and rewrote the code. It's like multi-methods were always fast enough. And yes, they're slow.
For some value of slow.
Yeah, but we don't. What you said is actually true. There's one of my favorite speakers to watch is Martin Thompson.
Right.
He does a lot of work with high frequency trading and the disruptor queue and that sort of stuff. And he has a saying where he says, immutable data structures are like sausage. They're all well and good until you go in the kitchen and see how they're made. And it's true. Like if you compare and assert, like, let's check the type of a value, but when it comes into a function, set, we're going to do set union. Make sure everything that comes into the set union call is a set. That check is way cheaper than the actual cost of adding something to an immutable collection, where you have to copy 3 arrays and copy all the values over and do a bunch of math. And it's like, it's way more expensive.
I mean, to me, immutable data structures are just like provably usable, which is great, I mean, because they give you a shitload of affordances as a programmer, which is what you want.
Oh, absolutely. Right. Yeah. So my point with that is, like, we've already taken the actual power of a CPU and reduced it down because we want certain conveniences of immutable data structures and that sort of thing. We've already cut whatever the throughput of our system, quote unquote, in half by using a dynamic language and using immutable data structures. And maybe someone forgot to type hint reflection somewhere in our Clojure code base, and then we're worried about, adding an assert. And in some cases, like, this is the thing I like to point out with people, that the hotspot JIT is really, really good. And so there was a time I actually went in and type hinted how much slower would the Clojure core set functions be if they just checked to make sure that their inputs were a hash set before they did any work. So put an assert. And it got faster with the assert. And I benchmarked that so many times, and it, as far as I can tell, it just realizes that, I don't have to do casts in the function. I used to have to do 5 casts, and now I know the input is of this type, so I don't have to cast anymore in these cases, and so it just removes a bunch of code, and So anyway, it's back to core async, I guess.
But I mean, I think the general point is that we're talking about, like, let's say the philosophy, aren't we, of whether you say it's optimized for correct programs. I'd like to see that somewhere written down in the Clojure, like, rationale or something. It doesn't seem like a decent rationale to me. I've heard Stu say it, but I don't know if
so Stu said it, and I'm not sure that I've ever heard Rich say it.
And I'm not trying to call Rich. I'm not trying to say that Stu is, wrong or something. If that's what it's optimized for, then fair enough. Let's have it out there. But it seems like a weird goal, to me.
Yeah, yeah, and I I think the problem maybe with that statement is that it doesn't recognize that there's uh, that all things, taking anything to the extreme, it's a problem,
Yeah, yeah,
right?
Yeah.
If we want to optimize everything for correct programs, then when I segfault in the JVM, it should crash my
mm,
computer, like the OS, everything.
yeah,
That
Yeah.
we do have certain safeguards in place. Hey, I used to program GW Basic, like I said, back in that day when you access memory you weren't supposed to, you had to hit the reset button and reboot
yeah,
DOS. So I don't really want to
Yeah.
go back to that.
yeah. Well, I've been doing some IoT programming recently, and it's like that still. You're
Right.
kind of like on the bare end of an operating system, which is really just a scheduler, and it's like, this is horrible. This is a really horrible experience in C at the arse end of civilization. It's not nice. It really isn't nice.
So I think the correct response to that is schedulers. We would have loved
Oh
schedulers
yeah.
back in my day. We had one thread.
Speaking of the type level stuff, so I hear many you programmed in Erlang, you programmed in Python, obviously, and other languages. So, what is your experience on the other side of this debate, like the fully static type checking stuff?
Yeah, so I forgot to mention a language there. So I was on the .NET platform before I went to Clojure. I was doing that at my day job, and so I spent some time in F#, and even
Yeah.
like I think I even played around with like adapting some of Clojure's concurrency semantics to F#. And then a couple weeks ago, I went back to F#. It's just like, hey, I was playing around with some programming language development ideas, and I wanted a language with tail calls, and so hey, F#.
Yeah.
And so that's my experience there, and yeah, I like it. It's one of those things where if I'm writing a compiler, static types really kind of help. I've done a lot of
Yeah.
work with the PyPy tool chain, which is statically typed but fully inferred. So you never specify types. They just it tries to go through your entire program. It's like, hey, your main input takes strings, an array of strings, and returns an integer. So based upon
Yeah.
that, we should be able to infer the entire rest of your code base. And so it just throws out an error at some point, like, hey, you used an int here and used a string here, and we can't unify this, So writing compilers and stuff, static types are kind of nice for that. Once you get into more data-driven systems,
Yeah.
that's when you want where the dynamic languages win out,
Yeah.
specifically data-driven languages like Clojure. So
Yeah, because I was thinking about the comment that you made, I don't know, a few minutes ago, that you said, build Clojure on top of Clojure, because one of the things that Haskell people say, that Haskell is one of the best languages to build other languages. Haskell is a really good compiler for other languages, so you can build on top of that one. And I also saw, maybe I didn't understand properly, in your GitHub, you have Clojure on F# or something like that?
Oh, Lisp, yeah. So I went a while
Yeah.
back and started just writing a Lisp on different platforms. And part of that was writing a Lisp in Lisp, and then making it so you could write the Lisp in a Lisp in a Lisp. And I have this cool file called, I think it's just called Deeper. And it just keeps loading a Lisp and a Lisp and a Lisp until your machine grinds to a halt. It's kind of a fun thing. But yeah, so it's kind of fun. So one of the things I really enjoy studying about this sort of thing is I watched a talk by, let me pull up the name of it here. Nada Amin did a talk a while back called Collapsing Towers of Interpreters.
Yeah.
And it's a work that she and another gentleman have been working on for some while. But it's kind of the idea of being able to write a language in a language in a language and have the runtime be able to collapse that down. So you can write a Lisp and a Lisp and a Lisp and a Lisp and a Lisp, and the final one is just as fast as the first one. And it does that through a weird form of partial evaluation and that sort of thing. And that's kind of what I've been spending a lot of my free time in is just kind of trying to unify that with other concepts I'd like to see in a programming language.
Yeah. So let's get to the other topic that we wanted to talk about. So how do you handle all these error messages in Clojure?
Yeah. So 110.
This is the topic of the year.
Yeah, 110's gotten better in that way.
Yeah.
Once 1.9 came around, well, actually, one spec was in core. I stopped reading the messages, frankly. Like I'll write a macro and I'll run the macro and it presents a wall of text, and it's just like, well, I just wrote 2 lines of code, so I can go stare at those lines of code or stare at this. I'm going to look at the lines of code. Yeah, so it was really bad. But yeah, I've used spec a couple times in projects, and most of the times I've ended up removing it after a while. It didn't quite give the power that I was looking for. And mostly just because it was so hard to debug. It's like my debug process a lot of times in spec revolved around you write a spec, your code doesn't fit the spec for whatever reason. It gives you an error. For some reason, it's hard to figure out why it's not that way. So go fire up the generators and have it generate some data that does fit the spec and see where you went wrong. And often it's, I wanted a vector spliced in this case instead of a nested vector or whatever.
Yeah.
So I mean, it's a self-fulfilling problem with spec, right?
It's optimized for perfect specs, Tim.
Yeah, right. No, but we do need better tooling.
Below the belt, that one.
No, I understand. No, we need better tooling for spec, but it's you need better hooks to write that tooling. So as an example, one of the reasons why I haven't used spec a lot is a lot of the code I write is data driven, which is funny to say in a Clojure.
You're not using spec for that.
Yeah, but in the sense that I worked on a system that didn't use spec, it used schema. And in schema, there's a prismatic schema. They have some other libraries with Swagger and the like. So you could write an HTTP endpoint. You write your spec, your schema, and then you say, "Hey, give me Swagger for this." And for those that aren't aware, it's a formal spec in JSON that's emitted out. And then there's a JavaScript thing you can put on the front end, and that's how we did our documentation. Was that we would write our schema and we would tell the other teams, "Here you go. If there's something you don't understand, tell us, and we'll update the spec to give you better documentation." That's technically possible in spec. In Clojure spec, but it's not reflective. Like once you have a spec, you can turn it back into the raw code that it came from, but you got to then interpret that code. Do you want to interpret that code using spec? And so then you get specs of specs and this whole thing. And it's like, what I really want is a data-driven system where I can tell spec, here is data that describes my schema. And at any time I can say, give me the data definition for that spec.
But what was is it just, of course, I understand the error message part of it, but what are the practical reason that you're not that keen on using spec in your programs? Because it does give some value, right? I mean, it will validate, you have all the generators coming out of the code that you've written.
Right. Yeah. So it's very much, there's no tooling for it. With schema, you can sit down and plug the little different libraries together and get your endpoint. And so at several jobs now, I several places I've worked at, the problem has very much been they already have an endpoint in schema that has, Swagger or this other stuff involved, and being able to and then that tooling doesn't exist in spec. So you can have a world where half your system is in spec, half is in schema. Sure, that's fine. But you got to maintain both. Or just really are we going to write a new system? If we're going to write a new system, we don't want to have to develop those libraries that hook up to Swagger or whatever.
I think it's a timing issue in some respects, though, isn't it, Tim? Because, you know, I would say that schema is pretty much on its way out. You know, they're not really loving it, because I think they see that the writing's on a wall, that people will start using spec for things. You know, and I agree with you. There's some lamentation there about that, because it's a very nice library and those guys did great work. On the other hand, I mean, for me, you know, I agree with you, and things Stu was saying the other day on our apropos thing, that he thinks that there will be more tooling and more data around spec, and that's obviously for the good, you know. But we tend to use it as for like greenfield stuff, for collaboration, just to kind of, you know, even if we would throw it all away, it's a kind of nice way to center the data definitions when you've got a team of people with with a lot of interfaces across the network, where you've got different people responsible for different things. Then spec seems to be pretty good at centering us all on, that's what we mean when we're sending this, that's what we mean when we're sending that. As a kind of discussion piece, it's nice, because if you do that in something else, it's not as easy to reify it. It's not as easy to say, oh yeah, this is what the actual data will look like, because those generators, as VJ says, are not there. So how do you do that with JSON, or how do you do that with a Word document, which is what we're faced with,
Right. And I think that's an interesting point, that in the real world, so to speak, your teams use different languages. Your front end team may be writing JavaScript, and your back end team's Clojure, or you got to talk to a Node.js service or something like that. And so the question becomes, how useful are those specs if no one else can read them, which they currently can't. So then it becomes a question of, can we translate them to something else? I mean, this is the way I think, right? It's like, if they want Swagger, or they want, some whatever format, whatever the flavor of the day is, I need a way then to extract data from the specs in order to generate that. Or I can go the other way.
By the way, the Matosin people are doing that. They've got some tooling to
but it's a little weird, in the sense that what you get is, you get S expressions. You got to parse S expressions, So like in a lot of my stuff, I want an AST, not Lisp code,
So of course, I mean, you've been building different types of languages and stuff, mostly Lisps on top of these things. So essentially, two-part question. One is that what is Pixie, and how are you building that one? And the other side of it is that just before we started, we were discussing, it's been 10 years of Clojure. So how should, in your opinion, a language should evolve around the community, and how should it be? What would be the ideal stewardship for a language?
Right. So this may go on for a little bit. I as long as you guys want to talk, I'm good to talk.
Of course.
Yes. Yeah. So let me know when you run out of hard drive space. But
it's like this Lisp running into Lisp. You just keep on talking until you run out of space.
Keep going. Exactly. Yeah. So to start with, for Pixie. So Pixie is funny. I originally started Pixie as a writing a Lisp on the PyPy platform. I could talk for some time about what I like about the PyPy tool chain, and it's got some really cool features. And there's not really, in the time I wrote Pixie too, that there's a packet, it's called a racket on the PyPy tool chain. But at the time there wasn't a whole lot of Lisps on there. So I wanted to do that and built some cool concepts into it. But also I didn't quite go far enough with it, in the sense that I ended up with something that looked like Clojure written on PyPy. And my focus now in a lot of languages that I'm working on, kind of the successor to Pixie, is I want to push immutability further into the language, make things like namespaces and even the entire interpreter itself immutable. And I had a branch on Pixie that did this for a while, and I didn't know how to make it fast. And that's been about 2 or 3 years ago. And I think we can actually make it usable now. But the whole idea of like what happens when each time you execute a function internally, you get a new copy of the interpreter, right? And that sounds crazy, but in essence, that's kind of the way some of these systems work. And you can optimize that, like with transients. Transients are immutable because nobody ever cares about the old version of the data structure, right? And so you can do some tricks like that to make it at any point you can say, get me a copy of the interpreter at this time. And you can do that.
Okay.
But going back to with Pixie, that's really kind of what I ended up with.
Tim? What do you want to do that for? What, apart from kind of like the satisfaction of doing it, what's the motivation for doing that?
Right. So there's a couple of papers I'll direct people to if they want to read up on this sort of stuff. So there's let's see here. Let me get the right one here. Programming with algebraic effects and handlers is a paper that talks about taking OCaml and putting an effect system in it. So OCaml is a language that is mostly immutable, but you have some escape hatches. And this algebraic effect system has a way of doing I/O in a functionally pure way without going to monads. So the return types of your functions don't change, but yet your entire program is immutable. And you do that through basically delimited continuations and some polymorphism and that sort of thing. So I would like to see that combined with some of the collapsing towers of interpreters. So I love metaprogramming and that sort of thing. And let's see here, the collapsing towers of interpreters is the paper you want to look at that. What they talk about there is like being able to write an interpreter and say, okay, I have a function that's my interpreter in my program, and I'm going to give it a program. And I want you to partially apply this program to the interpreter. And what you get out is a compiled function that is completely optimized for that program that you handed the interpreter. So it basically you never have to write a compiler is the thing. That you write a regex interpreter, you hand it a string, and it gives you a compiled function that is fully optimized to do what that regex was supposed to do. And you don't have to actually write a regex compiler. That's the goal for this sort of thing. So the problem with that sort of thing is if you partially apply a function, and you have side effects in that function, reading from disk, writing to disk, that's going to change the behavior of the function. And so my idea is to use this algebraic effect system to stub out I/O. So to basically say, you can think about it in Haskell or the like, you use the I/O monad to say, go run this function, but don't do the I/O yet. And so we're kind of going to put those two things together to say, I want a dynamic Lisp that is functionally pure, but doesn't use monads because I kind of hate monads, and allows us to do this sort of cool metaprogramming.
So why is your hatred for monads so pure, Tim?
No, really, it's just the types. The fact that if anyone's ever written a monad, it changes the function signature of your function.
Right. Yes,
right.
Of course.
So so if this thing uses a state monad, it no longer takes a string and returns an int. It takes a string and returns a state monad of int. And in a dynamic language, that's a fantastic way to drive you to drink, it's not so bad. So it's funny in F sharp. F sharp has these cool things called computational expressions. It's like the Go block, but as a first language, first class, as a first class thing, right? So you can say, hey, within here, redefine let as this and redefine do as this, and you can kind of within a block redefine all the basic language constructs, and that isn't hell on earth because of the type system that, when you actually try to compile it, it'll say, you know what, you said this is a let, but the values you take here aren't quite lining up. So you can kind of work with the compiler to make sense of that. But in a dynamic language, you don't have those safeguards. It's like, so why don't you just use types, Tim?
No, it's fun.
Yeah.
So that's the goal for Pixie for you then. So you want to have this immutability all the way down.
Yeah, so
Till the interpreter.
that's where I was kind of going with Pixie a while back, and I at this point I did enough. I don't want to say wrong. It's just I learned enough in the process of Pixie that I'll say it publicly. Pixie is I haven't touched Pixie in like 2-3 years, so it's not really a thing. But I am still prototyping some of these other ideas and ideas we learned or I learned in Pixie, and I'd like to build something with that.
Okay, cool. So the other part of the question was that, well, probably kind of an independent question. Was that there has been a lot of discussion, I think, on Twitter as well about the how the language was built and how the community is around Clojure and what are the priorities. So in your opinion, how should the language priorities change over the period when the language is getting bigger, and how do you see the community of Clojure?
Yeah, that's interesting. So I think you have to recognize that languages have kind of growth cycles, I guess, if you will, and that you always have the language hoppers that come on at the beginning.
Yeah.
That it's a new language, it's cool. I always wanted to learn a Lisp, and so here's a good Lisp, a modern Lisp. And there's also cycles, not even cycles, just growth in the programming community in general. I was thinking about this the other day, that when I started with Clojure, the idea of an immutable data structure, like you would say that and everyone's like, what are you talking about? And isn't that really slow? And this sort of thing. And you had to explain how, it's a little slower, but not enough that you care about. And people recognize that. I mentioned Martin Thompson earlier, but even he'll say in his talks that, if you're not in the core of your program, this stuff is still nice to have, I think he said that in one of his talks. And so today we fast forward to a point where almost every major language out there has immutable data structures, at least as a library. C#, Microsoft maintains their own immutable data structures as part of an add-on library for C#. And a lot of these features of Clojure we now see in other languages as well. So macros, Elixir has a pretty powerful macro system, and a lot of these sort of things. So when you talk about growing a language, I think you have to figure out where you want it to be. What do you want the language to be? Because if people just want immutable data and Ruby syntax, they're going to go to Elixir.
Yeah.
So on that note, I'm not sure where the designers of Clojure want to take it, but my impression is that they want it to be a powerful language that can be used by enterprise class companies to kind of harness the power that they have available, like the infrastructure they have available, as well as the kind of wrangle in the business complexities of the system. And it's one of those things where if you're optimizing for that, if you're optimizing for people that are going to spend 5 years, they're going to reroute their career to the language, then maybe some of these other things like error messages or some of this thing don't matter as much.
But does this view align? I don't want to put you. I don't want to put a lot of spotlight on you or something. But the idea is that the question is that, does that align with, because you worked within the guild of Clojure Core, and this view, is it something that you have seen already, or is it something that you're observing as a proxy?
It's something that I mostly observed as a proxy. So I should probably make that clear, that even in my time at Cognitect, I was not I wasn't part of the core team any more than anyone else is. I mean, I had the same rights and privileges that any person that wrote a patch did outside of Cognitect. But I think what my concern is there, that you have to have the young blood come in somehow, right? Is that if Clojure, you don't want Clojure to become a COBOL type thing where it's like only you must have a rack of 5 servers in order to use this language. Or or even you must be an AWS. I haven't
Yeah.
a lot of datomic and Clojure, the datomic ions and stuff you see going to AWS, and that's great. That's cool technology. On the other hand, I haven't worked on a project that uses AWS in about 4 years, just because
Mm.
all of the big companies I've worked for have their own infrastructure, or that
Yes.
sort of thing. And at some point you have to have the new people come in,
Mm.
and are they going to want to do that, or are they going to use Elixir, or
Some other
Scala, or
things.
Kotlin,
Yeah.
or whatever the newest
Yeah.
flavor of the day is. And so, for me, it's fascinating. I came to Clojure, and I found it a breath of fresh air, in the sense that I had never seen a tech conference like Clojure Conj, where you walk in and people are like, "So I read this paper."
Yeah.
Yeah.
The people that wrote Instaparse, the Engelbergs. I always
Yeah.
laugh at that. Apparently, that whole thing started when, like, hey, here's a paper on how to write a parser. Hey, son, go write this.
Yeah. Homework assignment.
And I'm trivializing it, but it was more or less along those lines. And that sort of stuff is cool. Core Match is the same way. That was developed by reading a paper. And
Yeah.
hey, I'll come out and say it. I don't see that anymore. I don't see that in the Clojure community. What we have today is kind of seems to be fitting things together. This new AWS technology, and we're going to fit it with this thing, and we're going to do this, and we're going to, but I don't know that says anything about the community, except that lost me, and that lost my excitement. That I don't, I came to Clojure as a compiler and programming nerd, and that spark seems to no longer be in the community. And maybe that's part of, it's just more mature now. But that's why I said what I did on Twitter, and that is, I look elsewhere now for development, like cool projects to work on, or new ideas, or that sort of thing. And let me be clear too. Part of that is just like, my ideas for what I want to write in a programming language are completely impossible on the JVM. The reason I haven't written this successor to Pixie yet is because I can't find a platform that supports the set of features that I need. And so it's like, how am I going to get delimited continuations and all this stuff into this language or that language? So.
But the whole AWS thing, I think that, so this is the contrast between the community versus a company, right? Because then I think from the company point of view, I can imagine that they're targeting specific demographic, which is going to, I don't know, give the revenue, obviously. But from the language point of view, I think one of the complaints, as I understood, probably is the lack of community participation, or maybe even I don't want to go that far, saying that it is like a discouragement or something. But this is the argument that I keep hearing from a lot of smart people who are in the community. So, is this something that do you think is going to be detrimental for Clojure, or is this something that is also giving you, I don't know, kind of a bad feeling about Clojure?
Well, yeah, I mean, I think it'll be interesting to see. It's interesting to see where that ends up. The problem is that it's never a fast thing. It's not like, I mean, any person who says, if I leave the Clojure community, or I leave this community, it's gonna die. It's like, no, it's not. I don't think that's the case. But over time, if you see the exodus of people, and those people aren't replaced, then we'll we may see a problem. I mean, and so to make it more concrete, that's what I see concerning about the Clojure community right now, is that we've gone from 2 conferences to 1. I don't know the numbers at the conference, but they haven't been increasing in size. When I've been to them in the past, they've kind of more or less the same size, maybe a little smaller. Last I heard, I don't think there's a Euro Clojure plan that not that I know of, and some of that's been picked up by the European community, and that's great. And so these are all things that in isolation are no big deal, but one at a time, I do question, what's the lifetime? What's the lifetime are we looking at?
Yeah.
I don't think closure is going away tomorrow
Of
or any
course.
time after that. But are we going to see a point where the enterprises are the only places that are using it? I mean, I've seen that kind of change over time as well. In that, you always skip the startups, the ones that are willing to take the risk, and then the larger companies, and there's some
Yeah.
large corporations that use closure now.
Mm.
But those also tend to be the tail end, right? They're the last ones to pick up the new technology. So is it going to be the situation where the startups stop using it altogether, and then you have the few enterprises, and then they move on, and then 10 years from now or something, that's it.
Yeah.
I don't know, but I think what I was going to say before too, it's part of building a community, that you have to, the community adapts to the point of view of the leadership. And I think you see this a lot. So I enjoy watching Twitch. It's this, streaming service where people play video games and you watch them, right?
Yeah.
And it's fascinating to me because there's some streamers, you go into their stream and they're my age, 35, they got multiple kids, they have been streaming for 5 or 6 years, highly professional, right? Someone says something in their chat room that's derogatory, and they just say, yeah, that person's banned. We don't talk like that around here, and over time, the whole community becomes very positive. It's this sort of everyone's encouraging. Someone makes a derogatory comment about someone, and it's like, hey, let's be positive. Let's encourage each other, and you contrast that with the, I'm going to generalize here, the 18-year-old kid who's shooting off his mouth all the time. And those are the ones that go on to some other streamer and just harass them or say the worst things, or, it's this type of thing that the energy, you have to put in energy to be an example of how people want, how you want people in the community to act, in other words. And I think maybe that's what we're lacking in the closure community it's maybe okay to say, yeah, it's for experts or that sort of thing. And it's tiring. Believe me, I've been in the place of trying to mentor people and encourage them and that sort of thing. And it is tiring. It's tiring to run an open source project where you have to explain for the 50th time why you didn't write it this way or that way.
Yes.
I get that. But if you ever stop, if you ever say, I don't want to explain it to you, not that someone said that, but if you give them the impression, I don't want to explain this to you because it would take too much time.
But I think we did cross the critical boundary, right? I mean, to have the longevity of the language. There are people. I think I always tend to see. I don't participate in Twitter that much because it's a very shitty.
You're a better man than me.
No, I'm basically there to do marketing. Every now and then I need to tweet something, and I'm so careful on saying anything these days. It's like I don't want to get into discussion because I don't have time to type the 280 characters and then come up with a better way, because English is not my native language. The other day I was just thinking, every team has Scrum Master, so how many Scrum slaves do we have? I'm like, okay, I shouldn't tweet about this shit now. So that level of shitty discussion I can't tolerate.
Yeah.
So anyway, so I was thinking, like, we did cross the boundary of or the big hurdle of having a huge community around it. But I think the stewardship is still with the core. So I think maybe if that becomes a bit more open, for every one person who is tweeting shit out there, there'll be probably 1,000 people who are not on Twitter and happily enjoying stuff. So that's the ratio, I would think.
I would hope so, and that's really the question here, right? Is there's no way to know. I have been told that, that came up, right? Someone's like, why are you crapping on the closure development process? There's hundreds of people that work towards this, and it's like, but there's not. I mean, I actually ran Git stats on closure, and there's 6 commits. Six people have committed to closure in the past year, and many of those were tickets that were submitted years ago. And And I see that's the problem with the discussion is
Mm.
and we don't really have a good way of having a meta discussion about this. I don't hold any ill will towards anyone involved here.
Of course,
But it's a
yeah.
self-reinforcing problem. The progress of
Mm.
closure is so slow because there's not enough people working on it. And there's not enough people working on it because the process is such that it bottlenecks, right? That
Yeah.
you have a very limited bandwidth of how patches get approved and submitted and that sort of thing. And so the question, the problem I came into is, okay, I write a patch, I submit it.
Mm.
I then wait for it to be looked at.
Mm.
Maybe a week, maybe a month or whatever, for someone to say yes, no, okay, that's good, that's bad. Once that's done, I have to, and someone says, no, you need to fix this thing. I have to get that message, go back, fix it, get back in the frame of mind of what was I doing. And the whole process is not optimized for my benefit as the contributor. If you read the contribution process for closure, it's optimized for the head developer of the project, right? The way patches are created, the way they're accepted, the tracking system, everything. I found myself spending sometimes, if there's a small typo, I spend more time creating the patch in the acceptable way than actually doing the work. And that just discourages involvement, because the question for me becomes, would I rather spend my time, some of it's going to be wasted, building the patch and getting in and doing all this, or something where I can have more of an impact.
Yeah, but I mean, Tim, I think there's two discussions here. We've talked about meta discussions, so I think it's a good one. I mean, to me, if there was a sort of process which was, you need to correct your typo, correct this, correct that, do your patch like this, do your patch like that, but that process was like 1 or 2 days, and the feedback loop was pretty quick. You were still in the frame, you still made the thing, and then you get it accepted because you've done everything that's been asked of you. Then you get it accepted, and then a week later you see, oh, it's merged. Fucking awesome. And I did that to ClojureScript, by the way, a few weeks ago. I've never done any committing to Clojure or ClojureScript, and I picked up a very tiny, tiny little problem. I mean, it was pathetic. It really was. But I thought, I'll go through the process of setting it all up, and it was nice. I mean, I don't like making all these patches and stuff like that, but the people who were doing it, who were reviewing it, were very supportive, very straightforward, and they corrected me on a few things, and even my code was wrong, and maybe you should do it like this, and wow, okay, I might as well have, I mean, basically they should have written it. But now I've got my name on a very tiny bit of ClojureScript code in their test suite. Great, I feel good about it, and I'll probably do a bit more. And that process of picking up the ticket, doing it, took me like a day, to get through all that process, and then maybe a couple of days to go backwards and forwards to get this. And again, it was totally trivial, but it was always active. Right. It was always like the feedback loop was always there. I never felt like it had been dropped into a kind of chasm. And I think that's what I find a little bit. When I look at the Jira tickets, on the Clojure side of that Jira, I'm like, this patch has been there for 5 fucking years. So someone says it doesn't work anymore. Everyone's lost interest. Why should I pick it up, make some changes to it, prove that it works with 1.10, for example, or prove that it fails and make some corrections for 1.10, and then let it wait another 5 years? I mean, I'm all for optimizations in some way, but for fuck's sake, things have to get through. That's not optimal anymore. If nothing ever gets through, it's not optimal.
Yeah, it's fascinating because I was thinking a lot about this the past couple of weeks. I realized, wait a minute, I do this every day at work. Like, the mentality on most projects in the professional space is you create the PR, you throw it up there. If someone doesn't comment on it in like 3 days, someone's probably just going to auto merge it.
Yeah, exactly.
It's like, apparently no one cared enough, and there is that, slap the hand thing where it's like, whoa, you committed something to master and it broke the build, so don't do that. But on the other hand, if I commit something to master and it doesn't break the build and it was bad, maybe we need better tests, or maybe, development, this or that or the other, and that really is, that's why what I said before is that it's optimized not for the contributor. It's optimized for the time of the head maintainer of the
I mean,
project.
see, the thing is, I look
Yeah.
at like two ways of this. I mean, I think there's kind of like there's let's say bugs and features. I mean, to me, like the way that bugs get fixed should be in a different channel to the way that features get introduced. Because if I've got I mean, I know this is a blurred line, but hear me out. In general, there's a column A and a column B, and I get that there's sometimes a little bit of both. But generally, if you've got a bug, you've got a test case, you can prove it, and I've got a line that can fix it, or 2 lines or whatever, and I'm not changing the behavior of this thing, apart from making it work as advertised, then that should go through pretty quickly, because you're not changing. All you're doing is fixing people's code. You're just making life better for everyone. Because they've got that feature. So that to me should be like, why the fuck doesn't that take 5 minutes, to get fixed? And then if someone wants a feature, somebody wants to write some library like Core Async or whatever, or some instrumentation for it, some extra things, then there's a discussion there about that, that's more wide ranging. And maybe that is like, well, I don't know if this is right. I don't know if it's in the spirit of the language or whatever. But have that discussion in the open, because then people can get used to what that spirit is, to what are the design flavors, the design, what's the phrase? The design, the design taste. There's a phrase for it. What are the
philosophy,
the design philosophy, the design patterns, what is it? What are people looking? What's the principles on which you're basing this thing? Because then I can write my code to match those principles, to match that philosophy, or I can just say fuck it. But for people that want to agree with you and say, okay, actually, I like your design taste. That's what I was looking for. I like your taste in design, and many people like Witcher's taste in design. But if it was a bit more obvious, like, well, yeah, I don't like this bit of code or that bit of code. I'm not very happy about that style of way of doing things or that way of doing things. If that was a bit more open, then my thinking is that you'd get more people contributing more stuff. If indeed you wanted to bottleneck it that way. If you don't want to bottleneck it that way, if you want to just say, okay, make it free, which is the way he wants to do it, obviously. So let's do it that way then. Let's be just more open about it, because then people will do what you want.
Yeah, and I think the thing, this has been said several times, but I think the thing people don't realize is that that's not the way Clojure is. I mean, and let's back up and say, for any of us, if we go and we spend a big chunk of our lives writing a programming language, writing a project, what is the incentive to listen to what anyone else has to say about it? And
well, can I say something about that? Because you can write what you want. If you've got 5 people using it, fuck them. They're your fans. So you can listen to them if you want to, but you can just say, look, guys, I know what I'm doing. And I'm doing it this way, so it's my time. Fuck off. I'm just carrying on. I'm just muscling through. And what you say, yeah, might give a shit, might not do. You've got 10,000 people using it. It's not like that anymore. Sorry, you were going to say that probably.
No, it's true. What you said is very true. But there's still no reason why they can't continue to exist in that way, right? As long as you're okay with the long-term consequences. And the long-term consequences is that some people, like myself, will say, Clojure is a fantastic language and I'll use it at work, but I'm past it now. I don't think that had to be the case. I think I would still be working on Core Async now if I was allowed to work on it as far as design. I could make improvements, bug fixes or whatever, but that's the extent of what I'm more or less allowed to do. But see, that's the thing, is if your goal is to write a language that you are happy using, that helps you with your work, then there's absolutely nothing wrong with running it the way the Clojure is.
Of course.
But it's not a long-term solution, I don't think, because there comes a point where people move on. And once the people move on, they're not going to ask their companies to use it. They're not going to,
Yeah.
But-
Support and
Yeah.
but concretely, I mean, do you think it's a good idea as a community to ask for something like Scala improvement process or PEP, something like that?
Yeah, I mean, it's
I'm just wondering because I think it's like we can keep on identifying the problem multiple times. I don't know if any of the I'm pretty sure at least 1 or 2% from Cognitect will listen to this stuff. So I'm just wondering, is this something that will help the people contributing to the ideas and the designs and the stuff like that? Because as Ray was pointing out, there are like two areas like bug fixes and then
yeah.
the feature stuff. The feature stuff could be like the closure improvement process or closure enhancement process, whatever we want to call it. I don't care. That more community input, for example.
Yeah, I think so. There's a fascinating thing here, in that I've met two types of people in the open source community, and I want to make this fairly clear. I'm not talking about Rich or Stu when I say this, but I have heard people say, why do I care what the community thinks? Because they don't understand the project like I do, or they're just a bunch of whiny people that want whatever feature, or even the bugs features thing, right? I've heard it said by people, one person's feature and one person's bug is another person's feature, right? It's like, and you can run to that problem in Clojure too, right? The fact that set union in Clojure takes vectors and actually does something, is that a feature or a bug, right? I could go in, I could fix all of that, but does that maintain backwards compatibility? I don't know. And that kind of goes back to what my thing with about building communities is I've also worked in other communities. I really recommend, there's a talk by Peter Hitchens back in, is that his name? I believe it's his name. Leader of the yes, I always use the wrong last name there. But Zero MQ, the leader of the Zero MQ community from back in 2013. And his philosophy around this sort of thing was doing what I said for PRs, but doing that for features, right? If someone wants to add a feature and everyone's like, yeah, sounds good, and that's just where the conversation ends, put the feature in, or they say, this is a feature I never use, I'm going to yank it out in this pull request, and it sits there for a month, and then or even a day or two, and it gets auto merged, right? Yeah. And then someone says, wait a minute, I used that feature. Or maybe they don't. The fact is that what if Clojure 11 or 1.11 doesn't have feature X that you use? So the question is, do you upgrade your code, or do you just not upgrade that version of Clojure? I mean, there's nothing that says that feature has to always exist, But I've that whole mentality is so foreign to some circles of open source development. That idea that we would just accept features that other people want, or they can go get their own project, let them fork it, build their own thing,
Of course.
I think just before we go on, I think there is a fetishization around backward compatibility, and I respect that, actually, because I think people do, people are writing their code, and I think it's a bit weird to break it. So I think that like the Zero MQ is like definitely an extreme way, for sure.
Yes.
It's an interesting way. I think from his perspective, it was a way to scale the project, because how are you going to Zero MQ? How are you going to scale it? I think everyone agrees this with every bit of software in the world, is that there's only a certain amount of time and space in the world, and people have only got so many hours in the day. So you need to have, if you're going to increase, if you're going to have more features, if you're going to have better features, you need to increase the bandwidth of that project. That's the only way to do it, or at least maintain that bandwidth and not have it brought down. So the question is, how much bandwidth do you want? Because that's a knob you can turn. That bandwidth can go up or down.
That's the question. that's the question I think we're at right
Yeah.
now in the Clojure community is how much do we need? I mean, I hear people say, I heard my coworker said it 4 years ago. I can't think of a feature that I want that Clojure doesn't have, and yeah, that's valid.
Yeah.
On the other hand, hey, it'd be nice if all of Clojure Core was spec'd,
Yeah.
and
Yeah.
that's a lot of work that would isn't being done, and we could
Yeah.
probably crowdsource something along those lines.
Yes.
But
some of it would be
Yeah.
my guess as well is a lot of that stuff, probably 80% of it, 90% of it would be uninteresting. It would be kind of just boring stuff. No one would really argue about it. But there would be 20%, which was actually I'm not quite sure how this works, or like the case you gave, But a lot of it is just boring stuff, it's just grunt work, basically, for want of a better phrase, that the community could easily pick up, and then you'd have some arguments, so you could put a pin in the ones that were more tricky. But that's how you increase the bandwidth. You don't necessarily have to decrease the quality. You can say, okay, I'm going to take 80% of this stuff and make an improvement over these things. And actually, you find out where the problems are that way, I think, having that discussion.
Yeah. Well, yeah. And I think what that requires, like you said, mentorship.
Yeah.
It requires, unfortunately, what it requires is the person with the authority to do the mentorship.
Yeah.
Because, hey, I worked in core async for a long time, and I can't tell you how many questions I answered of why doesn't core async do X? Well, I asked Rich about this and such and such. There's a problem there in that sometimes I don't agree with it. Maybe I agree with the person, but they asked why it doesn't have it, and the answer is that Rich has a counter argument of some sort, right? But that also introduces latency, right? If every time I ask a question of Alex, he has to ask Rich or whatever, that slows the process down.
Yeah. And obviously, that's great. He's going to get cranky about that, but he has to fix it. Why doesn't he just say, okay, I'm only going to take 3 questions a day, and only really super important ones. The other ones, let's just move forward. But
right. So that's what I mean by the optimization process. Is that I as a person who wants to contribute to Clojure have no way currently of talking to the person who makes the decisions about it.
Yeah, there's no devolution, basically. There's no trust. There's no. I mean, like there is trust, obviously, but that trust is very, very tightly controlled. Of who actually does all this kind of committing to the core.
Right. Any question I ask is filtered through Alex, and then perhaps to Rich, or maybe Alex can answer my question or whatever. Right. But there's signal loss. It's playing the telephone game and that sort of thing. And so if you and so it's an optimized process where now, yes, Rich can focus on the things that are important. The cost of that, I believe, is then you lose people that maybe would have wanted to help.
So I think how many hours have you spent in Skyrim so far?
Yeah, I looked that up actually just the other day. It's like over 400, somewhere in there. So
cool. Because I started playing Skyrim on Xbox mostly, and then to a point where like my wife started managing my Skyrim life, and then I had to ask her, oh, where is this I don't know, ebony, whatever the thingy, and she's like, oh, that's in Whiterun, in this the upper level, and in the drawer. And so we started managing the whole shit, and then I'm like, okay, this is the time I should stop now.
Yes.
But one of the best games ever I played.
It is very much, and for those who ever care, it is fascinating to me that the entire game is basically developed on top of a database. So all the items, all the locations have a record-based database, and people have backward engineered it in Pascal of all languages, Delphi. There's like no JS wrappers for that library and stuff. So the cool thing is you have programmatic wrappers to the database format, so you can add add-ons and mods to the game that say, hey, let's go through and give every bandit in the entire game a health potion so he lives longer. And things like that. And the other thing that's done, it's just on PC, there's this thing called SKSE, which is written by a bunch of developers who won't give out their names because they work for gaming companies, but they reverse engineered the executable. So they found out where all the C++ classes are in the game and installed hooks. So they extended the in-game scripting engine with hooks. It's basically a virus. You load up SKSE, it loads up Skyrim with all its hooks in it. And you can do all sorts of crazy stuff. Of course, once you get to like 200 mods or 400 mods, it gets to be a mess. So there's a thing called Mod Organizer that adds another layer on that. And it reroutes all the file system commands in the game. So whenever the Skyrim says, go get this texture from disk, it reroutes it through Mod Organizer and it says, oh, that's in this folder here. So it keeps all of your mods in a very organized place and then rearranges the file structure. And
I'm not at that level.
Yeah. And then there's another thing called ENB that hooks into the graphics driver and rewrites all the graphics routines to have better graphics. So the three of those things together are the core of any modded setup. And now you know why I have no time for Emacs.
So your Emacs is Skyrim.
Yeah, exactly. It's like I hear people talk about Emacs and it's like, wow, I can tell to you about form IDs and how those are ordered and affect the why that guy in that game at that position has a different color head than a body. I can tell you that, but I don't have time to tell you about Emacs or learn it. You know?
I think we should have a Skyrim episode.
Yeah. It's fantastic. An 11-year-old game that continues to have new improvements done every day by modders. It's something like 200,000 mods out there for it.
Shit. Wow.
Yeah.
Maybe that's where Clojure will end up then.
Yeah. Right.
I think everybody will start patching everything.
Maybe that's the thing that makes Rich break out in a sweat at night.
I have actually thought of combining SKSE with a REPL so I can have a Clojure REPL into Skyrim.
But that is going to happen pretty soon with Arcadia and all that shit, right? I mean, once we have that one, then you have a REPL, and then you can do whatever you like.
Crazy stuff.
That'll be super fun. Okay. Anyway, so of course, even you're spending all the day writing Clojure stuff still. So what are maybe a couple of things that you actually enjoy within Clojure?
Yeah, absolutely. So I mean, Clojure continues to be just. The thing that continues to astound me about it is how fast it is. I write some database code that does optimizations, logic engines, stuff like that. And you write some optimization pass that's like ON something or other. And then you run it and you're like, oh, it's going to be slow. And it completes in 23 milliseconds or whatever. And you're like, okay, that works. And that thing uses multi-methods and allocates memory all over the place. And it's just shocking to me how fast Clojure is for what it does. Almost every enterprise place I've worked at, I've looked at code and I'm like, this is slow. This is going to be terrible. And then you look at your web response times and it's like 200 milliseconds and no one cares at that point. It's fast enough.
Yeah.
So, in that sense, Clojure is a huge success in the sense that it's a language that I want to use every day at work. And a lot of that is due to Clojure's pragmatism. The fact that it runs on the JVM and doesn't try to do silly stuff like make everything a Go macro.
So you had that one. You had that PR ban, did you?
Well, no. I mean, so like Erlang is Erlang on the JVM. And the funny thing is, Erlang is actually faster than Erlang. Or at least it was last I checked. Just because the JVM is that fast, but they do full program.
I think JRuby was like that, wasn't it? Actually,
no, Pulsar. Pulsar is a library that does that for Clojure. So as you load your classes, it rewrites them using a Go macro type thing. So your entire program your entire service is written in that style, and it's transparent, and that's great. But of course, you have trade-offs.
Trade-offs,
of course.
Yeah.
Okay. I think we are almost 1 hour 45 minutes. Wow.
Right.
Well, hey,
that's a pretty
pushed it out a little bit. Yeah. Just it's good that the clocks went back today in Europe because otherwise it would be.
Of course, your biological clocks are still probably like stuck on the other times, right?
I have no idea. So I think I still feel like it's 9 o'clock or something.
Yeah.
I think. Yeah. Anyway, so any, of course, Tim, when you have to come back because we probably there are a lot of other topics that we want to discuss, and
yeah, it's been really good,
especially with the logic programming stuff. Any concluding thoughts?
Yeah, that's a good question.
Apart from everybody should play Skyrim.
Yeah, play Skyrim. No, yeah, it's I guess keep learning. About 4 years ago, I read a paper on mini-canron, mu-canron, the logic programming stuff, and that's I've done so much work on that in the past few years professionally. If you don't understand the philosophy I've always had in computer programming is if you don't understand something, that's fine, but if you want to, pick a time and just decide you're going to become an expert, or at least become dangerous in that thing, right? At one point I didn't understand how networking works, protocols, wiring, IP addresses and all that. And I focused on that for a year. And at the end of the year, I helped the school I was at, I helped rewrite the whole network system, and we switched to a NAT based system and cool. Multiple subnets and VPNs or, VLANs and that stuff. And hey, it was enough to be dangerous with, right? Yeah. Same thing with logic engines, a lot of closure.
No one can get in that machine, in that school anymore now. But
right, yeah, right. No, but if you don't understand, closure or a Lisp or something, sit down and just give it a year or something of free time.
I think or
even maybe not that much.
I think what's nice is that because we I don't know if we're accused of it or proud of it, but we this is a very closure focused podcast, and it's it's all about closure and the community and the kind of the programming language and the people and all that kind of stuff, and I think that's really good. But it is nice also to kind of explore what's outside of that echo chamber, and have different things. Like you say, Elixir is an interesting language. F# is an interesting language. There are plenty of languages out there that are kind of interesting. I got into OCaml myself recently, and I'm not going to leave the bar with OCaml, Right. I've still got my main squeeze, but I like to look occasionally. I'm sorry, And I think it's got some deficiencies, some things I don't like about it, but there's certainly some nice things, some advantages for smaller platforms, and so it's nice to talk to people like you who've got such a breadth of experience in programming languages and and core skills like that to understand some of the benefits of looking around, and also some of the kind of different perspectives that are around in this huge world of programming.
Yeah, absolutely. I have a fascination for programming semantics, data flow programming, logic programming, constraint programming. There's all these different ways, not just imperative and declarative, but there's dynamic and static and untyped languages, and the list goes on. There's what is the Wikipedia thing? I think it's just programming paradigms. Is the Wikipedia article? I think it is. But on the right side of the page, there's just a list of 20 different programming paradigms: object-oriented, functional, constraint-based, and start rating them. Just what is a constraint-based programming? What does that mean? How's that different from a logic programming? How's it different from and there's lots of stuff out there, and it's fascinating. And like you said, there is a certain amount of an echo chamber in any language. There's this philosophy in languages that if your language doesn't have a way of talking about something, you have a problem understanding it. And so they've done some experience with this, and depending who you believe it's real or not, but that in some cultures they would call a certain color of green and a certain color of blue the same color, and that we see the difference in westernized cultures, but in these other cultures that's the same color. But they had 30 variants of blue that we can never see. And so as I look at that in programming, it's the same sort of thing. It's if a function is just a procedure call, you're not even going to think about higher order programming or even be able to reason in that concept. So yeah, it behooves us to think about things that we could do if we weren't limited by the JVM or limited by any language or specific platform.
Yeah. Okay, so again, I think it's time to conclude for this episode at least. Thanks a lot, Tim, for all the hard work and co-racing and all of the things.
Absolutely.
And especially, I think I'm not sure if you're gonna produce more learning closure.
Yeah. I've done some videos of that in the past, and I probably will in the future. I'm
Yeah.
not quite sure where we'll go with that, but
so what was the URL again? Sorry,
Is it on YouTube?
Oh yeah. For the videos and stuff I do.
Yeah.
So the site I'm on is called PivotShare. That's kind of like YouTube, but they have a better subscription model than YouTube. So it's Baldridge at .pivotshare.com. Actually, just Closure Videos, I think, too.
Yeah, Closure Videos by
videos.com, I think. Let me make sure that is the domain. That's it. Yeah, so closurevideos.com. And
so check that out. And then, of course, I mean, hopefully you will continue working in Closure more and more.
Oh, I'm sure.
And then,
I mean,
and then one day.
Yeah, it's Closure's not going anywhere soon. I'm not going to switch languages any soon. It's not.
No.
It's a,
of course. I mean,
you compared it earlier to some sort of dating situation, right? It's not a a violent breakup or anything. It's just, it's like, what could have been,
Yeah.
It
is not you. It is Pixie.
Yeah,
but it's okay.
right. Yeah. Well, yeah. But that's that fun research project. That's something that I think it was Craig Undera was a coworker of mine who I think he was the one who brought this up. That's the importance. It was either him or Mike Fogus. I forget which one of them talked about the importance of just having ideas. Prototype the idea, throw it away.
Yeah.
You don't have to finish something to learn
exactly.
something from.
So, yeah. Okay, so on that bombshell, we'll try to conclude this 2-hour episode. Probably, I think we'll make it 2 episodes. I'm not sure. Then obviously we'll reach 42.
There you go.
That's finally.
I got the holy number. Yes.
Maybe it's 41A and 41B. I'm sorry to spoil the party.
I will just skip 42 completely until Tim comes back again, and then we'll say,
we'll bring you back to 30 and 37. Okay.
There we go.
And okay, that's it from us for today. Fantastic discussion again. We'll see you around on the internet, Tim. Hopefully you'll come back and then give us more of your wisdom.
I look forward to it. Well, it's coming back. I don't know about wisdom.
Right. Stay on the line, though. We're going to stop the YouTube, but stay on the line.
All right. Sounds good.
Bye-bye.